Next program is program 3. Program 3 using NumPy pandas and matplotlib demonstrate the following operations for the sample dataset. So first one is central tendency. So central tendency mainly if you want to find the mean or central point in a dataset, or if you want to find the mode or median, for that we are using central tendency. So first here we are going to do central tendency mean. So mean is average of a set of numbers. So here by using list, I created a variable name called nums and inserted the value 1, 2, 3, 5, 5, 9, 9, 9, 9. And by using mean function, and this mean function is defined in statistics package. So you have to import statistics as st, any variable name you can give. So st dot mean function, open bracket, closing bracket. Inside that, I pass this list name called nums. And after executing this, you will get a value 5.375 that indicates the average of these numbers. Next one is we are going to do next central tendency, that is mode. So mode returns a frequently occurring number in a particular data. So here you can see 9 is frequently occurring in the data set. So when you pass that variable name nums in mode function, this mode is also defined in statistics package. So st dot mode and nums. After executing, you will get 9 because 9 is occurring 3 times. The next is median. Median means the middle number. So middle number you will get. So in this data set, middle number is 5. If it is an even one, then sum you have to take and divided by 2. That is the median value. So here it is 5. Next one. So these are the three things that comes under central tendency. Next one is dispersion and distribution. That means variance and standard deviation. So variance is defined in the function called variance, and it is defined in the package called statistics. So st dot variance, and you just pass the list that we created. So you will get the variance of the data. Next one is standard deviation. So standard deviation we are going to find by using stdev function, and that is defined in statistics. So st dot stdev, and the value is going to pass here. So we will get standard deviation. Next one is, third one is ANOVA testing. So when it comes to ANOVA testing, we are doing this ANOVA testing by taking the four lists. These 4 lists indicates the engine performance, oil performance for each and every engine. Performance 1, performance 2, performance 3, and performance 4. And we are using for testing ANOVA testing, we are using a function called f_one way, and we are passing all these engine performance values. And it will return 2 values. The main value is p value. So p value is less than 0.05 means we are accepting the hypothesis. So that is what is called ANOVA testing. Next one is is-set testing or hypothesis testing. So when it comes to is-set testing, here so next one is hypothesis testing. So when it comes to hypothesis testing, first what you have to do is you have to import math library, then NumPy and NumPy package, NumPy.random, and statsmodel.stats.bstats. So here, what we are going to do is, here we are generating a random array of 50 numbers having mean 110 and standard deviation 50. Similar to the IQ score data we are seeing above. And mean equal to 110 and standard deviation is we are finding for that particular value, and alpha we are assuming 0.05 and null mean equal to 100, and we are going to print mean and standard deviation. Now we perform the test. In this function, we passed data, and in the value parameter, we pass mean value in the null hypothesis and in alternate hypothesis. We check whether the mean is large or not. So for that, we are using a function called z-test. So here you can see this is z-test. So it will return two values. One is z-test underscore score and p-value. So for hypothesis testing, we are going to use this p-value. If the p-value is less than this alpha value 0.05 means we will reject the null hypothesis. Otherwise, we will accept null hypothesis. So that is represented here. So once we execute this, we can see in this case, we reject the null hypothesis. So these are the four programs. One is central tendency, dispersion and distribution, ANOVA, and hypothesis testing.